Okay, so if we look at any angle in the xy plane and think about it as an angle of rotation, then we can compute the trig functions using some basic facts. The first fact we can use is our little moniker, all students take calculus. This helps us see if by hand we can decide which trig functions will be positive and which will be negative. And we can also use the Pythagorean theorem and the relationship between x and y and the radius in order to compute some trig functions by hand. So you're going to need to be able to compute these showing your work on the xy plane and in addition to using your calculator. It will be expected that you can explain and show your work and give exact answers, not decimals that come out of the calculator. So in order to do this, we're going to use something called a reference angle and a reference triangle. And we're going to use some of our previously found special triangles also in these examples. So let's just start with any angle theta in the standard position with the point negative square root of 3, 1 on its terminal side. So you need to know that square root of 3 is approximately 1.7, so the location of this point at negative square root of 3 and 1 is in quadrant 2. So you can see here, negative square root of 3 is about negative 1.7 and 1 is where I placed P on my xy plane. This is called the standard side, and the terminal side, the initial side. So theta is this full angle here. It's obtuse, it's greater than 90 degrees. So this doesn't create a right triangle though. Theta is outside a right triangle because theta is more than 90 degrees. So what we use is something called a reference triangle, something that gives us an acute right triangle. I'm always going to take a reference triangle with a reference angle here with the x-axis. You can see I've made it here in orange. And then I can use this little angle here, I'm going to call it theta prime, as my reference angle. So I recreated this little reference triangle over here, and using what I know about the xy plane, I have a y distance of 1, an x distance of negative square root of 3, and then I use the Pythagorean theorem to figure out the length of the radius. So negative square root of 3 squared plus 1 squared is r squared. That gives me 3 plus 1 is r squared. 4 is r squared. So if I take the square root of both sides, the radius is always a positive distance, so the radius is 2, and I went ahead and labeled that here. So using that reference angle, I can figure out the sine, cosine, and tangent of my original theta if I just keep the signs in mind. So all students take calculus tells me that I should expect in quadrant 2 that sine will be positive, but cosine and tangent will be negative. So using my reference triangle, sine of theta is opposite over hypotenuse, so 1 over 2. Cosine of theta is adjacent over hypotenuse, so adjacent is negative square root of 3 because we were in quadrant 2 with a negative x value over 2. And tangent theta is opposite over adjacent, so that's 1 over negative square root of 3, but when I rationalize that, it gives me negative square root of 3 over 3. These are the answers I'll be expecting from you, not the decimal approximations out of your calculator. So you're going to need to be able to show your reference triangle, always taken with the x-axis, which will give you an acute angle here, and your right triangle trigonometry as a way to compute your trig functions. So there are some common ones that pop up a lot, those 30, 60, 90, and 45, 45, 90 triangles. So here what I've done for you is I've made the 3 basic reference triangles already computed with side 1 and 1 for our 45, 45, 90 triangle and square root of 2 as the length of the radius. You can go back 2 videos ago and see how we computed that using the Pythagorean theorem. Here's your reference triangle for 30 degrees, and here's your reference triangle for 60 degrees. So these come in really handy because they come up a lot, and if you know these ratios, you can get a lot of angles out by hand. So we're going to try that right now using a reference triangle to compute the 3 basic trig functions for theta equals 240. So just to review, if we start at 0 degrees and we move around in terms of degrees, then the y-axis represents an angle of 90 degrees. The other side of the x-axis is 180. The bottom part of the y-axis creates an angle of 270, and then a full rotation, as we discussed before, would be 360. So an angle of 240 degrees is in quadrant 3. So I went ahead and created that angle, which creates an obtuse angle, but it does give me here a right triangle if I use the x-axis for my reference angle. Always use the x-axis for your reference triangle. Never use the y-axis. Your reference triangle should always be taken with the x-axis. So here, I have to kind of do a little bit of math that if I know I went from 0 to 90 and 90 to 180, then this remaining angle here is 60 degrees, because 180 plus 60 gives me 240. So here you can see I've chosen 60 degrees to be my reference angle. The angle made with the x-axis should always be the reference angle, not the angle, never the angle made with the y-axis. So labeling my triangle, I'm here with a negative x, so negative length 1, using my reference triangle above for 60, negative 1, a vertical distance of negative radical 3, and a radius, which is always a positive distance of 2. So I'm using this reference triangle to label it, with my reference angle down here being 60 degrees. So in quadrant 3, all students take calculus tells me that the tangent should be positive. So we'll check it out. Sine of 240 degrees using my reference angle will be opposite over hypotenuse, so negative square root of 3 over 2. That worked out to be negative. Cosine of 240 is adjacent to hypotenuse, or negative 1/2. And that ends up being negative. And then tangent of 240 is opposite over adjacent, or negative square root of 3 divided by negative 1, which reduces to a positive square root of 3, which we expected because we were in quadrant 3.